Hi guys, today we are going to look at the ruler postulate, distance, and between. And this is going for our day 5 notes in unit 1. So the first question asks, how many points are contained in a line and why? So the correct answer here is actually there's an infinite number of points. Because that's just by the definition of a line. Lines contain an infinite number of points. So even though in this picture there are only 8 points that are shown, there's actually a point at -1, there's a point at -3, there's a point at +3, there's a 7, 8, 9, 10. It goes on forever in both directions, therefore giving us an infinite number of points. So when we look at number 2, it says name 2 points whose distance from E is 3. So if E is 1, if we go 3 away, we can go in both directions. So from E, we go F, 3, G. So G is 3 points away. And we can go in the opposite direction. So 0, -1, -2 is C. Now you name 2 points whose distance from C is 2. You should have gotten that D and A are both 2 units away from C. 1, 2, and 1, 2. Remember that CH without a bar over the top represents the length of CH. So if I want to find the length of CH, I can do it algebraically by doing 5 minus -2. So the coordinates of H minus the coordinates of C to equal 7. Or you can think about it as the absolute value of 5 minus -2. If you do big minus little, the absolute value isn't necessary. If you don't, the absolute value is necessary. Or you could always count it. So starting at C, I go 1, 2, 3, 4, 5, 6, 7. The main thing to remember is to fill in any missing coordinates. Now you find the length of IA. You should have found that the length of IA is 10 because you go from -4 to +6. So you would do 6 minus -4, which is 10. 6 through 11 should be pretty easy. You're finding the distance of the coordinates. So if you always do big minus little, then you could always remember that. But also remember that you're doing the absolute value. So I could just as easily say the absolute value of -8 minus 4, which is the absolute value of -12, which is 12. Go ahead, take a few seconds, and do the rest of these problems through number 11. And then come back to check your work. Checking your work, you find that for number 8, you get 7.5, 10 is 13, 7 is 1, and 9 is 25. I left number 11 off so we could talk about that one together. So if you are on a number line and you know A and B, but you don't know their actual position, you're really just doing whatever the bigger one is minus the little one. So you're doing B minus A. But we don't always know that B is the bigger number. In all of these examples, like in 8, 10, 9, and 6, B was the bigger number, but in 7 it wasn't. So you just need to make sure you take the absolute value of that so that you make sure your answer is positive. Looking at number 12, we have points R, S, and T that are distinct and collinear. Distinct meaning they are their own points, collinear meaning they all lie on the same line. In each case, you want to draw a number line representing the situation given, then tell which point is between the other two. So while at face value, this looks like it would be fairly easy, it can be a little bit tricky. So you want to think about what makes sense. It's kind of like a logic puzzle. One trick is to say, okay, RT is definitely the biggest segment here. And 10 is bigger than 7 and 3. So that means that RT is the entire segment. And that length is 10. Then that leaves S in the middle somewhere, so that ST is 3 and RS is 7. I didn't draw it to scale, but that's okay. So then we know that S is in between. It was kind of easy to see that because S is in both segments. But we'll see in a minute that that's not always the case. So looking at 13, we see R is in both of these, but we see that ST is actually the longest segment. So that means that ST are our endpoints. So even though R was in both of these two, so since R was in both of these two, we know it's in the middle, but S was also in both. So you want to look for the longest side and put those as the endpoints. So then we know the length of ST is 14. Now we can put R somewhere in the middle, and we know that RS is 6 and TR is 8. So R is in between. You guys try and do number 14 and then check back to check your answer. Since ST was the longest segment, you should have seen that S and T would be your endpoints with R in the middle. So then you can see how that one goes together. This leaves you with R in between. Now looking ahead to number 15. We have that RS is equal to 10 and RT is equal to 14. So the length of RS is 10 and the length of RT is 14. The coordinate of S is at 7 and the coordinate of T is at 3. So I would start with my coordinates here. So start with saying, all right, I know that S is at 7 and T is at 3. Number lines always go in the same direction. So for positive numbers, the 3 has to be lower than the 7. So that means S has to be here and T has to be here. Now we need to think about what are the lengths of the other segments with R. So we see that RS is 10 and RT is 14. That means the length of RT needs to be longer than the length of RS. If I put R over here, then RS will now be longer than RT, which doesn't make sense for what they've told us. So my R needs to go out on the other side because R needs to be closer to S than it is to T. So then I know that SR, or RS, did not draw very well, is 10, while RT, which is the entire length, is 14. To get the coordinate of R, you can either take 3 plus 14 to get 17, or you could do 7 plus 10 to also get 17. You want to double check both of them. So R is 17. You try and see if you can figure out 16. Start again at your coordinates. So the coordinate of S is -2. The coordinate of R is 0. That means that S needs to be to the left of R. So here's S and here's R. Actually, I'm going to write those letters at the top. So we know that S is at -2 and R is at 0. Now, thinking about the fact that TS needs to be 7 and TR needs to be 9, I need TR to be longer than TS. If I put T over here, then TR will be shorter than TS. So I know that it needs to go onto the opposite side. And I put these too close over here, so I'm going to move them here. So I'm going to put T over here. So then I know that TS needs to be 7 and TR needs to be none. So you ask yourself, what point would T need to be 9 units away from 0? And that would be negative 9. Negative 2 minus 7 is also 9. So we know that T is in the right spot. So T is negative 9. You always want to kind of guess and check and use whatever logic you can when you're doing these problems. This last point, or this last section deals with, they tell us that point B is between A and C. So they're telling you where the point is. It's B in the middle. A and C are your endpoints. Then they're telling you that the coordinate of A is at A, the coordinate of B is at little b, and the coordinate of C is at little c. So you're going to make a number line for each situation. So your number line is either going to look like this, or it's going to be the other way with the little letters on the bottom. So let's look at number 17. It says the coordinate of A is at 1, the coordinate of B is at 2. The length of BC is 6. We need to find C. Since we know that A is at 1 and B is at 2, we can go ahead and put those two down. So we know that the A has to be a positive 1 and B has to be a positive 2. So we know they're in that order. They've now told us that the length of BC is 6. Since we know that B is in the middle, then we know C has to be on this end of B. Because otherwise, B wouldn't be in the middle and A would be. So this has to be C. So we know that the length of this is 6. So in order to find what the coordinate of C is, we would just take 2 and then add 6 to get 8. So C is 8, or the coordinate of C is 8. Going on to number 18, we have that the coordinate of B is 7, the coordinate of C is 3. So when we put those down, we know B is in the middle at 7. So C has to be down here at 3 based off of our number line. That makes A have to be on the other side of B over here. And since we know that AB is 4, we can do 7 plus 4 to get 11. So A is equal to 11. So that one was kind of backwards from what we would normally done. Now let's look at number 19. 19 tells us that if AB is equal to BC, so that means those two lengths are the same, making B our midpoint. And then we have C at a coordinate of negative 2 and B at a coordinate of 4. We need to find the coordinate of A. So we know B is in the middle. Since we know that B is in the middle, that means that, and it is at a coordinate of 4, that means that C has to be this endpoint since it's at negative 2, making A at the top. Since we know that these two lengths are the same, we can find the length here is 6 because negative 2 minus 4 and the absolute value gives us 6. So that means that this distance needs to be 6. So 6 away from 4 makes A at 10. So A is equal to 10. Take a couple minutes and finish 20, 21, and 22, and then check back your answers. 20 and 21 were both fairly self-explanatory. Since C is 10 for number 20 and A is 20, we know that C has to be lower than A, and since BC is 6, then B has to be at 16. Same thing for 21, A is negative 5 and C is 7, so we know negative 5 has to be on the left and C has to be on the right. Giving a length of BC of 5 means that B is 5 away from 7, which is 2. 22 is a little bit trickier, but with a little common sense, it's not too bad. So since they told us that A is at 7 and the AB is 4, and then BC is 6, we can have that stuff. But knowing that B is greater than C means that A has to be the greatest coordinate at the right because C has to be the furthest to the left so that B can be a greater coordinate than it, making that, giving this picture in blue. Then I can say, okay, well, from 7 to B is a distance of 4, so 7 minus 4 is 3. And then going another 6 down gets me to -3 for C. You could also think 6 and 4 is 10, so a distance of 10 from A would give you -3 as well. Tomorrow we'll answer any questions on this, as well as have some extra practice in class. See you then.